The distributive property, what should you try to do first before you treat it like a regular two-step equation? Well, what we want to do is get it to look like a two-step equation. So we're going to work our best using the distributive property and this other thing called combining like terms. And what those will do is that'll help us in order to get it to look like a two-step equation so that we can handle it a little bit easier. Now, let's do a little bit of a review first. Let's remind ourselves the parts of a term. We have the first part here, that's called the coefficient. This part here is called the variable, and then this little part up here is called the exponent. Now, we want to combine like terms. We want to make sure that we're looking at the variable and the exponent so that we're able to know what goes together. We want to make sure that we understand that an x squared and an x to the first term are two different terms. They do not combine. So we got to really make sure we're looking at the parts of a term and kind of concentrating on the variable and the exponent to let us know what's alike. So let's do a little practice here. Here we have 3x plus 2x. If we have our 3x's and 2x's, the variables are the same, the exponent is the same, so we can put them together and say that there are 5x's, 3 plus 2. We can do the same thing again here. Here we have an x squared and an x squared. Again, the variables are the same, the exponents are the same, so if we have 1x squared and 1x squared, together we have 2x squared. Let's try a few more. Here we're looking at a little bit more involved problem, 3x plus 2 minus 2x minus 1. And we're going to look for like terms. Here we have a 3x, and this is a minus 2x. So when we put those together, we have to keep that in mind. So 3x minus 2x is a single x. And then positive 2 and a negative 1 is a positive 1. And these will not go together because they are not alike. Here we have an example 4a minus 2a plus 2. And again, we're going to take a look at this and put together things that are alike. This 4a minus 2a. 4a minus 2a is 2a. And this 2 doesn't belong to anything else, so it's just going to come along for the ride and be out there. Now let's talk a little bit about the distributive property. The word distribute means to give out, to make sure that everybody has something. So we want to think about it in that terms so that everybody gets some. So I have a little graphic here that'll help us to describe it. Outside the parentheses, we might have a number or a variable. Here we have a bag of money and some people inside who aren't looking too happy. And what we want to do is to give the money out to everybody, not just to one person, not to be choosy, but to everybody. And what that does is it makes everybody happy, obviously. So we want to make sure that when we're practicing the distributive property, that we are indeed giving everything out to every person or every term that's inside. So now let's take that a little bit more and apply it to some math. So here we have 3, and inside the parentheses, times x plus 4. We're going to give the 3 out to both of the terms. So we'll have 3 times x, which is 3x. Then 3 times positive 4, which is positive 12. We'll do it again here in example 6. We'll take 2 times 2y minus 1, and we'll take the 2 and give it to the 2y, and the 2 and give it to the negative 1. 2 times 2y is 4y, and 2 times negative 1 is negative 2. So here we have 4y minus 2. Hopefully that explains a little bit more about combining like terms. I do like to mention a couple of things. One thing is that we notice that it can be used with addition or subtraction, which we just showed in those 2 examples. The other is that we want to be aware of double negatives. What do I mean by double negatives? That means if I have a negative out here and I have a negative on the inside, we got to make sure that we're watching our signs. So let's practice with this problem, negative 3 times x minus 4. If I give the negative 3 to the x, I will get negative 3x. If I give the negative 3 to the negative 4, a negative times a negative is a positive. So 3 times 4 is 12. So we want to beware and be on the lookout for those double negatives. Now, since multi-step equations include not only distributive property, but also combining like terms, we want to make sure that we determine what our process is going to be. So we'll take a look at some steps. First, we'll take a look and decide, will we need to distribute? If we need to distribute, only if it's necessary will we do that. We'll also take a look to see, do we need to combine like terms? Again, only if it's necessary. One or both, or maybe neither will be required, but sometimes with multi-step equations, we're going to require a few of these. Then we're back to our usual, our use inverse operations with the constant, the one with no variable first. That means we're going to add or subtract. And then we're going to use inverse operations with the coefficient of the variable term. That's the second one we're going to work with. And we're going to multiply or divide that. Remember, we always need to check our answer. So let's take a look here at this problem. I have 7x minus 3x plus 4 equals 6. So on this problem, we have to combine some terms that are alike on the side. Here we have 7x minus 3x. We know that to be 4x. And then we bring down the rest of our terms. So now we have 4x plus 4 equals 6. We'll start to work on the constant on the side with the variable. So we're going to subtract 4 from both sides. That's the inverse of adding 4. Positive 4 and negative 4 go to 0, so that goes away. We don't have to worry about it. And we're left with 4x equals 6 take away 4, which is 2. Now, since we have 4 times x, the inverse of multiplying would be dividing. So we're going to divide both sides by 4. And this 4 divided by 4 becomes a big 1. 1 times x is x. And 2 divided by 4 is 1/2. I know we might be a little alarmed about getting a 1/2, but most of algebra is a fraction. And so we shouldn't be afraid of running into that. So 7 times 1/2 minus 3 times 1/2 plus 4 equals 6. So what we're going to do is to rewrite these a little bit so that we can combine more terms. So 7 times 1 in the numerator would be 7. 1 times 2 in the denominator would be 2. Here we're going to subtract, and we're going to do the same thing with the 3. 3 times 1 in the numerator is 3. 1 times 2 in the denominator is 2. Plus 4 equals 6. So here I have 7/2 minus 3/2. 7/2 minus 3/2 is 4/2. So I have 4/2 plus 4 equals 6. I can reduce that 4 divided by 2 to be 2. And then 2 plus 4 is equal to 6. And since both sides are exactly the same now, I know that my correct answer is x equals 1/2. Let's take a look at another problem here. Here I have 2 times 3x minus 2 equals 20. What we need to do first is to use the distributive property. We're going to give the 2 out to the 3x, but also out to the negative 2. We'll have 2 times 3x, which is 6x, and 2 times negative 2, which is negative 4, equals 20. Then we're going to start to use our inverse operations because we're down to 2 terms. So we'll start with the constant first. So instead of subtracting 4, we're going to add 4 to both sides. And those 4s will cancel, leaving us with 6x, and 20 plus 4 is 24. Then we're going to divide both sides by 6 because we're multiplying the variable by 6, and we want to do the inverse. Cancels that out, leaving us x equals 24 divided by 6 is 4. We need to check our solution by plugging this answer of 4 back in where the x is to make sure that it works. So 2 times 3, and in the x spot, we're going to put a 4 minus 2, and that equals 20. We're going to work from the parentheses, so we've got to do the multiplying first. So 3 times 4 is 12. Then within the parentheses, 12 minus 2 is 10. 2 times 10 is 20. And since both sides are now identical, this answer of 4 does work out. Let's do one more problem where we're kind of doing everything all together. Here we have negative 10 equals 8 times 2x plus 3, and we're going to subtract 18 from that. So we're going to work on the right side, and we don't really care which side we're working on, just we're working on the side where the variable lies. So here we have 8 times 2x, which would give us 16x, and we're also going to give the 8 out to the 3, and 8 times 3 is 24. We do not give the 8 to the negative 18 because it's not in the parentheses, so it's just going to come along for the ride. So now what we need to do is we need to combine some terms because we have 3 terms on this side. This 24 and 18 need to go together. So 24 plus 18 is a positive 6. So now we're at our 2-step equation. So we're going to subtract 6 from both sides, and we end up with negative 16 equals 16x. Then we're going to divide both sides by 16 to isolate that variable. That gives us 1 times x, which is equal to x, and negative 16 divided by 16, which is negative 1. We're then going to check our solution by plugging it into the original problem in that spot right there. So negative 10 equals 8 times 2 times negative 1 plus 3, the whole thing, subtract 18. So we'll start from the parentheses. 2 times negative 1 is negative 2. Then what we'll do is combine what's inside the parentheses, a negative 2 plus 3, which is 1. Multiply 8 times 1, which is 8, and then subtract 8 minus 18, and that's negative 10. So that checks out. So indeed, our answer is negative 1. So hopefully this helps you a little bit more using the distributive property and combining like terms in doing equations.